Okay, we are starting with a new topic called polynomial. Now, as the name suggests, basically it is, as Manas has been saying, that it is several terms put together is a polynomial. That is how you are discussing this polynomial in school. At that level, correct, whatever you have said about polynomials before I really start this recording was not completely correct, but by and large it was correct. You have a correct understanding of polynomials. But now what we are supposed to do is we are supposed to put everything in proper place. We have to define everything that we use and use it very precisely. Because if we by and large know what do we mean by polynomials and we do not know the exact definitions, we can be put under pressure, we can be put in trouble by a very well designed question. Okay, and maybe here are some examples which I would like to give. As you have said correctly, it is an expression where there are terms and it is going to be a an expression with different terms. Then when I ask you whether 1 plus x square plus x cube, something like this, is a polynomial or not, then many of you said yes, this is a polynomial, but Jaydeep said no, this is not polynomial. So there is a difference between this and 1 plus x square plus x cube, full stop. There is a difference between these two. Okay, and maybe this is what we are interested in, and what is this is what we will call as polynomial maybe. And if I have set some pattern over here, like first term is x raised to 0, second term is x raised to 1, third term is x raised to 2, and so on. If the pattern is, if I say that this pattern will continue forever for infinitely many terms, therefore this dot dot dot, or maybe I can say 1 plus 2x plus 3x square plus 4x cube, this pattern will continue for many terms, or I specify whatever is the pattern, I specify and leave it to that. And there are practically infinitely many terms in this case. We are not going to not polynomial. And the word for this kind of expression we have in maths is called power series. Okay, power series, because you keep on whatever number of terms you want, you can write. And it is also very useful identity. Eventually in differential calculus we will use this power series to represent very complicated functions. This is the easiest expression, algebraic expression that we can have, and we will be able to write this kind of expressions for complicated functions that we will do in differential calculus in 11th standard. But presently what we are interested in is not the things of this kind plus dot dot dot, but there is an end, they stop. Maybe x raised to 100, maybe another polynomial could be y raised to 100 plus 50 times y raised to 3 plus y square plus 8. Yes, fair enough. This is polynomial because it stops. It stops means after a particular degree, after a particular index of the variable, all the coefficients after that are 0. What I mean to say is 0 y raised to 102 plus 0 y raised to 101 plus 0 y raised to 100 plus 50, I mean all in between are 0, plus 50y cube plus y. Again, power 1 is coefficient is 0, etc. So plus 0y raised to 1000. I mean, I can always have higher power terms, but their coefficients are going to be 0. Okay, and therefore this is not the case in this power series. In power series, I mean, they are present. Maybe there will be few with coefficient 0, fair enough, but they are present. It is not going to happen in power series that after a particular power of x, every coefficient is 0. If it happens, then it becomes a polynomial. समझते का? So normally polynomials are written in this form: p of x is equal to a0 plus a1x a2x square plus something like plus an x raised to n, something like this. An expression of this kind is a polynomial. Expression of this kind is a polynomial, and we say that it is polynomial p of x belongs to r of x. P of x belongs to r of x. What does this mean? This means p of x is something like this: finitely many terms, indices are whole numbers, correct? We don't have any term x raised to minus 3 in this, not allowed. Clean, no denominator, clean terms as far as x is concerned. Okay, and it belongs to r of x means all the coefficients a0, a1, a2, dot 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 an are real numbers. Belong to real. That is the meaning of this, and this is your variable. I mean, I can write p of y belongs to r of, maybe tomorrow if you learn complex numbers, it will be polynomial y in complex numbers. Sorry, not x, y. Something like this. What does this mean? Your coefficients can be complex coefficients, complex numbers, and it is a polynomial with the variable y. That is the notation. Okay, now we have not done definition of polynomial yet. I am just describing or trying to add to what you have said. Yes, then the term called degree. You said the highest. In this case, the degree is going to be 100. In this case, the degree is going to be 3. Suppose now p of x has degree 3, x cube plus 2x square plus x plus 1. Q of x has also degree 3. Okay, and if I add them, few of you have said, or majority of you have said, that the degree will continue to remain 3. But it is not true, because if I have q of x something like this, and if I add them, p of x plus q of x, what will happen? I will have 7x square plus 2x plus 0, and p of x plus q of x has degree 2, whereas p of x has degree 3, q of x has degree 3, but p of x plus q of x has degree less than 3. If this was plus, then it could have been 3. So at most you can have degree which is maximum amongst p of x and q of x. You can still be, if I just take p of x, if I take r of x, another polynomial r of x as minus x cube minus 2x square minus x minus 1, and if I add p of x plus r of x, I get 0. Okay, so degree of the summation of polynomial is going to be equal to or less than maximum amongst the two. Okay, so that is what is the correction for addition of degrees. I will get back. I will come back to all the definitions and we will write down everything systematically. But I'm just trying to correct what you were saying and what is the deficiency in that and how do we correct it. Okay, then similar question can be asked about P of x has a degree P. Q of x has degree Q. Then P of x into Q of x has degree, you said, equal to P plus Q. That is what you said.
Sir, it can be 0 if it is 0.
Can be 0. Yes. So again, we need some correction there. If P is a polynomial, P of x is a polynomial with any of these P and Q is 0. If any of these P and Q is 0, then P plus Q is not, is it not going to work? Will it work?
No, sir, it would be 0.
Why?
The only case will be if P of x or Q of x, if either one is 0, then the product it will it will be 0. So the power it might vary.
Or it might vary. So if P is small p is equal to 0, chalega?
No, sir, I was talking about the polynomial. Like, suppose we have P of x. If P of x is equal to 0, meaning the polynomial basically it's the number 0. So if we multiply both of them, we will get the product as 0. So, and
Okay,
0 may
okay,
have 0 may have
okay.
varying power.
Oh, you are right. So now let us spend little time about degree. Okay, so now 3x square plus 2x plus 1. What is the degree of this polynomial? 2.
2.
5x plus 7. What is the degree of this polynomial? 1. Correct? 8. What is the degree of this polynomial? 8.
0.
0. And 0. What is the degree of this polynomial?
Sir, don't know.
It can be any real number. It can be any whole number.
Can be any whole number. Okay. So there is a confusion about the degree of
0.
polynomial which is actually only 0. Which is only 0. There is always going to be a confusion. There is 0 is always going to trouble us. 0 will trouble us in real numbers or
Sir,
maybe
is it undefined?
we will discuss. Wait. 0 in real numbers will trouble us or may help us. I mean, 0 has got dual role to play. It helps us many times, but it troubles us also sometimes. If we put 0 in the denominator of any finite number, 0 is going to trouble us. We cannot divide by 0. That is the story of real numbers. 0 will trouble us in complex numbers. 0 will trouble us in vectors. 0 will trouble us in matrices. 0 will keep on troubling you. Whenever you try to do new thing, 0 will trouble you. Now we are dealing with polynomials. We will be troubled by 0. Because should we call 0 as a polynomial? If we take stand yes, then we are supposed to report the degree of polynomial. There we say no, we cannot report degree of polynomial if the coefficient is only 0. We cannot deny that 0 is not, we cannot say that only 0 is not a polynomial. I mean, we cannot say that also. Therefore, we have to give special treatment to 0 every time in every field of maths we deal with. The moment you try to develop something new, we have to take care of these people like 0 and we will take care. So we will call this as 0 polynomial. We call it as zero polynomial. Zero polynomial is special case, very, very special case. Any other constant other than 0 is a polynomial which is non-zero polynomial having degree 0, because 8x raised to 0 is the polynomial. This is 8x raised to 0 is a polynomial with degree 0. But I mean, we will be in trouble if it is 0. So we are not saying that it is not defined. Yeah, maybe if we define what degree is, that in that case we might not be able to define degree of 0 polynomial, right? अरे इथपर्यंत सगळ्यांना समजतंय का मी काय सांगतोय ते?
Yes, sir.
Important. And these are some counter examples for the conventional things which are being remembered, which are being discussed majority of the cases with majority of the students. So these counter examples, if polynomial itself is 0, it will create everybody 0 to whom it is getting multiplied to, no matter whether it is a 100-degree polynomial or 1000-degree polynomial. If it gets multiplied to 0 polynomial, degree will vanish, it will become 0 polynomial, and you cannot say anything about degree of that product polynomial. Therefore, if we want to say something about degree of product polynomial, either it will be 0 polynomial or its degree will be p plus q. That is how we have to say. Okay. Okay.
And sir, in division also one thing is involved, that we are dividing by non-zero polynomial.
Hmm. Yes, correct. But then multiplication and division, we take them together. Addition and subtraction, we take them together. So in this, essentially every time we will discuss addition and multiplication, and subtraction and division will follow. Okay. So this is very good discussion. Therefore, I would like to give you the formal definition of polynomials, which you should write and remember. Write and remember formal definition of polynomials. Polynomials. An expression where each of AI is a real number, and two, only finitely many AIs are non-zero. It's called polynomial over reals. Polynomial over real numbers. Now let us understand what do we mean by this. As I have explained you earlier, all AIs must be real numbers, but then it can be power series. In power series also all coefficients are real numbers. If it is a power series over real numbers, all coefficients are real numbers. And second point is important, which you need to remember, as it is only finitely many AIs are non-zero. Infinitely many AIs are non-zero, it becomes a power series. Finitely many AIs are non-zero, it becomes polynomial. right? This is what is the definition of polynomial. Immediately we define zero polynomial, an expression immediately we define zero polynomial. Let a of x belong to R of x, polynomial over reals. Let a of x is equal to a0 plus a1x plus an x raised to n, or maybe we need not write this because we are not sure where to stop. Okay, let ax is equal to a0 plus a1x plus a2x square plus dot 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 if each of ai is 0, then a of x is zero polynomial. Check whether you understand it. Definition number 1, definition number 2, definition number 3. Let a of x belong to R of x. Let a of x is equal to a0 plus a1x plus a2x square plus dot 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 n belongs to whole number. It's said to be degree of a of x if what do you think? We will call n, which is a whole number, degree of this polynomial a of x. What should happen if condition number 1 bola a of n should not be equal to 0, compulsory. A of n should not be equal to 0. And what should happen? Second, if for every m belonging to natural number, हे करते हैं ना, हे बोल ना मी, for every m belonging to natural number such that m is greater than n, am is equal to 0. After n, everybody is 0. That is the meaning of this statement. Then we will say n is a degree of a of x. Okay. Let me pause this recording for a while so that you can complete it. Equality of two polynomials. Definition number 4. Let b of x belong to R of x. Let b of x is equal to b0 plus b1x plus b2x square plus dot dot dot. We say that a of x is equal to b of x. A of x is equal to b of x if and only if bola.
Each AI equal to BI.
Yes,
AI equal to PI.
an is equal to bn for every n greater than or equal to 0 or I वापरायचा असेल तर I वापरायचा.
Sir,
Yes,
but there shouldn't be this dot 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 at the end of all the polynomials, otherwise they technically aren't polynomials.
now we are writing ax is a polynomial over real, that is written here. Now we have already defined this notation, and whenever we write like this we understand that it is a polynomial. Okay, you can write a n raised to x, n x raised to n, but then we are saying that degree is n, therefore I am not writing it here. Okay, so ai is equal to bi for every I greater than equal to 0. Corresponding coefficients are equal. So in English, two polynomials are equal if corresponding coefficients are equal. Okay. Now I have a job for you. Let
So is this fifth?
hmm?
Is this fifth, sir?
No, this is not definite. It is theorem eventually. So let a of x belongs to R of x. Let a of x is equal to a0 plus a1x plus a2x square plus dot dot dot. Let b of x belongs to R of x. Let b of x is equal to b0 plus b1x plus b2x square plus dot dot dot. Let n belongs to whole numbers. Let us define Ci is equal to ai plus bi for every I greater than equal to 0. Consider C of x, which is equal to C0 plus C1x plus C2x square plus dot dot dot. Then C of x is also polynomials over real numbers. Instead of real numbers, we can say reals. So this is theorem. And I give you little time to write down the proof of this theorem. if we add two polynomials and if we create a new polynomial by adding their coefficients, corresponding coefficients, then whatever algebraic expression that we get is a polynomial. I will run through. What we must prove is that there are only finitely many CIs which are non-zero. We have to satisfy the definition of polynomial. C of x must satisfy definition of polynomials. Okay, so we consider two cases because we have not been given that a of x and b of x are non-zero polynomials. So one of them can be zero polynomial, or both of them can be zero polynomials, or none of them can be zero. But if both of them are zero polynomials, then it is the very easy case, and therefore we are not considering it. Eventually after addition, the new polynomial will also be zero polynomial. So case 1 which we are considering is at least one of a of x or b of x is a zero polynomial. So without loss of generality, WLG, without loss of generality, we can consider a of x is a zero polynomial. We can always consider b of x also as a zero polynomial. So any one of them is zero polynomial. Then suppose a of x is a zero polynomial, that means all ai's are zero. So we have been given that ci is equal to ai plus bi, so 0 plus bi, therefore bi. Therefore ci, the new polynomial's coefficients, will be equal to coefficients of polynomial bx. So it will be actually c of x will be equal to b of x. Both these polynomials will be equal because the addition polynomial a of x is zero polynomial. So therefore it is a polynomial. We have proved case number 1. Case number 2, none of them is zero polynomial. That means they have some degree. So let the degree of a of x be capital A, which implies that the coefficient of power a, that is a of capital A, is not zero, and every other coefficient greater than capital A is zero. Degree of b of x is capital B, then the highest power coefficient, that is b of b, is not zero, and every other coefficient which is greater than capital B is zero. Okay. Now amongst these two, capital A and capital B, you choose the maximum one. Okay, and then if you now happen to choose n which is greater than c, both of them are going to be n is going to be greater than both of them, a and b. Hence an and bn will be 0. So cn also will be 0. That means we have proved after choosing maximum amongst a and b, the coefficients after that are going to be 0, and hence there are finitely many ci's which are non-zero, and therefore c of x is a polynomial. That is
Sir,
how.
I did not understand that from the fourth last step. Like let C be equal to max and a comma b. So how did we come to the deduction that n should be greater than a and n should be greater than b?
Yes. So example. Suppose degree of a of x, degree of a of x is equal to 5. Degree of b of x is equal to 3. Okay, so capital A is 5, capital B is 3. Now choose, let capital C be equal to maximum 5 comma 3. So what will be the value of C? C will be equal to 5, right? Yes or no? Now if I choose n which is greater than C, which is equal to n greater than 5, suppose I choose n is equal to 7. So 7 will be greater than 5, which is capital A. So 7 is greater than 5. This is C is greater than A. Sorry, not C. N is greater than. This implies n is greater than A. 7 is greater than 3. Implies similar to n is greater than b. Every time it will happen because you are choosing maximum amongst these two as c, and then n is still greater than c. Therefore, it will be greater than a as well as greater than b. Namaste.
Yes, sir.
Hmm. Okay, good. Have you completed writing? This is what is the systematic, complete, correct proof of this theorem. So now next theorem will be related to the degree of addition polynomial. So I will pause the video. Next theorem is about the degree of summation polynomial. Let a and b of x are polynomial over real. Let none of them be zero polynomial. Then new polynomial ax plus bx is either a zero polynomial, or in other case degree of a of x plus b of x polynomial will be less than or equal to degree of a of x maximum of degree of a of x comma degree of b of x. Have you understood this statement? Then I think it is easy to write the proof. The way we have written the proof of above theorem, it will be easy for us to write the proof of this. You may try it for 5 minutes. I give it to you. You try to write it the way systematically we have written this first proof. You try to write it for the second one. Okay. Proof is let degree of a of x be capital A. We have done this in the earlier proof. The coefficient is non-zero and every coefficient after that is zero. Let b of x be capital B. The largest coefficient is not zero and coefficient after that is zero. Without loss of generality, let a be smaller than or equal to b. They might have equal degrees. Okay. Now, if you consider any natural number which is greater than b, of course, Cn is going to be 0 because An is 0 and Bn is 0. Therefore, C of x is a polynomial. Suppose its degree is capital C. Degree of that is capital C. Then C is always going to be less than or equal to B. C is always going to be less than or equal to B because of this fact that C of n is always going to be 0 for any n greater than or for any n greater than b. So if your n is, so n can be, if you want coefficient to be non-zero, C of n to be non-zero, then n has to be either equal to b or less than b. N cannot be greater than b. It is more or less indirect method of proving it also, but we have not really shown the contradiction. We have directly written. समझता है? Okay, let me pause this. This is really deep into the theory of polynomials. Very rarely people will study this. Those who are dealing with polynomials will just start stating the theorems without getting into the proofs of it. The advantage of getting into the proofs is, number one, you start understanding abstract algebra. I mean, writing these proofs in this way. See, taking numerical examples and showing that it works like that is one part of the story. But converting those numerical examples into a generalized notation and converting those examples into proofs is really one notch up study that we are trying to do. And now you see, if you write couple of proofs like this, you will be very fluent in writing these kind of proofs. This experience of writing proofs of this kind of algebra, abstract algebra, will certainly help you in dealing with proofs related to calculus later on. Because see, geometry is one part of the story, and geometric proofs, once understood how to write, there is a support of those figures, diagrams available, which we can make use and complete our proofs. Majority of the time, the diagram itself will prove it. However, in this case, there is nothing, no diagram. It's complete visualization, and that is why it is little difficult, and that is why we teach it in 9th standard. You are little mature to understand this. Okay, so now the biggest part of polynomials will come, which is what do we mean by product of two polynomials, that is one, and how do we establish and prove that its degree is going to be something like summation of the degrees, etc. So maybe we just begin with the discussion. That is what we want to do for product of polynomials, but writing theorem and writing proof of the theorem will be done in the next lecture. Okay, so let us just develop the experience of multiplying two polynomials. ईशान हात वर केला होतास म्हणे तू, मेसेज आला मला, तू हात वर का केलास? ईशान रेज्ड हँड म्हणून आला मला मेसेज, नाही ना, चुकून?
चुकून झाला असेल.
ओके ओके, नो प्रॉब्लेम. चला. So what I am going to do now is I will give you some experience about, let me use the sideways now. Okay. Let us suppose I write a of x is equal to 5x cube plus 2x square plus x minus 1. B of x is equal to 3x square plus 2x minus 5. Find a of x into b of x. This is the simplest exercise that I can give you. Without making any error in any of the coefficients, find out what is product polynomial. It will look like x raised to 5, 15 x raised to 5. Then x raised to 4. Coefficient of x raised to 4, 10 plus 6, 60. Plus coefficient of x raised to 3, minus 25 plus 3 minus 22 plus 4 minus 22 plus 4, 18 plus x
minus 18.
minus 18, yes. X square, I cannot get x square here, minus 10 plus 2, 8 minus 8 minus 3 minus 11. Coefficient of x minus 5 minus 2, 7. Constant 5. Is that correct? So this is what is product. So if a of x is equal to a0 plus a1x plus a2x square plus dot 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 plus a of x raised to a and b of x is equal to b0 plus b1x plus b2x square plus dot 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 plus b of x raised to b, the and full stop. Let c of x is equal to a of x into b of x. Now, can I really write it like this, or I have to prove that c of x is a polynomial. Okay, or let me consider it. Consider then. So I mean, I am actually writing the theorem, but we are not going to do it today. What I want you to do is, what I want you to do is, okay, what I will do is, I will make this little easy. A 8 into x raised to 8, b 7 into x raised to 7. Okay, product. Now I want to find coefficient of x raised to 10 in ax into bx. Okay, that is what is the exercise. What will be the coefficient of x raised to 10 look like in this expansion? Yeah. Okay, so the answer for this is sigma I goes from 0 to 15 ai bk minus I. Now, this answer, if we just use it for earlier problem, then there will be 3 more terms in the beginning and 2 terms in the end, and all those new 5 terms are going to be 0, because first 3 terms are 0 because of b, and last 2 terms are 0 because of a, and you end up getting these 6 terms if k was 10. So in general, sigma I goes from 0 to 15 ai b k minus I is going to be the coefficient of x raised to k. Okay, that is where we stop for the day. I send you the next homework. You do it and we will discuss in the next lecture. It is already 9 o'clock.